Welcome back, Murari Maths online classes. Today we discuss about previous year JEE mains questions. Chapter name is limits. Okay, now explain first question. What is the statement? Limit x tends to 0, sin square x by root 2 minus root under 1 plus cos x. So now expression 0 substitute. What is the form? 0 by 0 form. This is. Now we should use rationalization method. So limit x tends to 0, sin square x. Here divide multiplied by x square. Why? Because sin square x by x square value 1. Here, what is the denominator value? Root 2 minus root under 1 plus cos x. Here, we should divide and multiply root 2 plus root under 1 plus cos x. Okay. So, sin square x by x square, according to Sandwich theorem, this value 1. As limit x tends to 0, sin x by x is equal to 1. This is 1. Limit x tends to 0, x square into. So, in the place of cos x, in the place of x, write 0 here. Root 2 plus root under 1 plus cos 0 upon here denominator we should write a minus b into a plus b. What is the form? A square minus b square. So a square is nothing but root 2 whole square is 2. Root of b square is nothing but root 1 plus cos x whole square is 1 plus cos x. Okay. Now limit x tends to 0. X square into root 2 plus root 2 we get 2 root 2. The denominator value how much? 2 minus 1 minus cos x is nothing but 1 minus cos x. The denominator 1 x square divide and multiply. Why? Because we have one formula, limit x tends to 0. 1 minus cos x by x square is 1 by 2. Here x square get cancelled. Okay. Now limit x tends to 0. Root 2 plus root 2, 2 root 2 by 1 by 2. What we get answer? 4 root 2. Okay, let us go to the next problem. So what is the statement? Limit x tends to infinity. 1 plus a by x minus 4 by x square whole to the power 2x is equal to e cube. Then find out a value. So now expression infinity substitute what we get here? 1 to the power infinity. 1 plus this is 0, 0. So 1 plus 0 minus 0 power infinity. 1 to the power infinity, one formula is there. So e to the power limit x tends to a power into base minus 1. What is the formula? Limit x tends to a f of x power g of x is equal to e to the power limit x tends to a g of x into f of x minus 1. Okay. So e power limit x tends to infinity. What is the power here? 2x. What is the base here? 1 plus a by x minus 4 by x square. Power into base minus 1. Okay. Is equal to e to the power 3. So here plus 1 minus 1 get cancelled. So limit e to the power limit x tends to infinity 2x multiplied all. What we get here? 2x into a by x plus 2x into minus 4 by x square. Here one x cancelled. Here bases equal, powers are equal. So 2a plus in the place of x, right, infinity, minus 4 by infinity is nothing but 0. 2a plus 0 is equal to 3a, we get 3 by 2. Okay, let us go to the next problem. Limit x tends to 1 minus root pi minus root under 2 sin inverse x by root 1 minus x. Now expression 1 substitute here only. This is the 0 by 0 form. Okay, and now we should use rationalization method. Limit x tends to 1 minus, what is the here numerator value? Root pi minus root 2 sin inverse x. So you divide multiplied by here, root pi plus root 2 sin inverse x. So limit x tends to 1 minus, here numerator we should use a minus b into a plus b. So what is the formula? A square minus b square. A square we get root pi whole square. Root pi whole square, root square get cancelled. Here root 2 sin inverse x whole square, root square get cancelled here. So what we get here? Limit here pi minus 2 sin inverse x. Here pi minus 2 sin inverse x. Pi minus 2 sin inverse x. I will take 2 common here. Pi by 2 minus sin inverse x upon root 1 minus x into root pi plus sin inverse in the place of x, right, 1. So 2 sin inverse 1. Sin inverse 1 we get pi by 2. 2 into pi by 2 is root pi. The root pi plus root pi, how much? 2 root pi. So pi by 2 minus sin inverse x. Because we have one formula, sin inverse x plus cos inverse x is equal to pi by 2. Okay. So pi by 2 minus sin inverse x is nothing but cos inverse x by root under 1 minus x. So root pi plus root pi here, 2 root pi, numerator 2 is there, 1 2 get cancelled here. So now expression 0 substitution, what we get here, this is the 0 by 0 form. So now we should use LH property. So 1 by root pi constant here, limit extends to 1 minus. So what is the L'Hospital rule? Differentiation of cos inverse x, we get minus 1 by root 1 minus x square. So a denominator root function derivative is 1 by 2 root 1 minus x into under root minus x derivative is minus 1. 1 minus x derivative is minus 1. Here 1 by root pi times of limit extends to 1 minus. So what is the here? Minus 1 by root 1 minus x square. Here we should use a square minus b square, a minus b into a plus b. Root 1 minus x into root 1 plus x upon minus 1 by 2 root 1 minus x. So 1 root under 1 minus x get cancelled here. So 1 by root pi, limit extends to 1 minus. So what we get here, here minus cancelled. So 1 by root 1 plus x into 2. The denominator 2 here, right? Into 2. So in the place of x, write 1, what we get here? So 1 plus 1. So 1 by root 2. So 1 by root pi into 2 by root 2 is nothing but 1 root 2 get cancelled in numerator. So root under 2 by pi. This is the answer. Okay, now moving to next question. What is the statement here? Let alpha and beta be the roots of the ax square plus bx plus c is equal to 0. Then find out this limit value. Okay. So what are roots here? Ax square plus bx plus c having roots alpha and beta. Therefore, ax square plus bx plus c is equal to a times of x minus alpha into x minus beta. The limit extends to alpha 1 minus cos. Here ax square plus bx plus c relation we should write a into x minus alpha into x minus beta by what is the denominator here? X minus alpha whole square. The limit extends to alpha. So we have 1 minus cos theta. So 1 minus cos theta formula is 2 sin square theta by 2. So according to this formula, what we get here, theta value a into x minus alpha into x minus beta. So 2 sin square theta by 2. This is theta by 2. Okay. So denominator, what is the denominator here? X minus alpha whole square. Here we should multiply divide by we should multiply divide with a square into x minus beta whole square. A square into x minus beta whole square by 4. So why? Because here, according to sandwich theorem, this value how much? 1 square. So next step written. Limit extends to alpha sine of a into x minus alpha into x minus beta by 2 by a times of x minus alpha into x minus beta by 2 whole square. So what is the here? A square into in the place of x, right? Here x reaches to alpha, x place in that alpha. So a into a square into alpha minus beta whole square by 2. So what is the form here? So limit extends to alpha sine a into x minus alpha x minus beta by 2 by a into x minus alpha into x minus beta by 2 whole square. This is the according to sandwich theorem, this value 1. So 1 square. 1 square into this value, a square into alpha minus beta whole square by 2 answer. What is the sandwich theorem? Limit theta tends to 0. Sin theta by theta is equal to 1. Okay, let us go to the next problem. So what is the statement given? 2 times of limit h tends to 0 root 3 sine pi by 6 plus h minus cos pi by 6 plus h upon root 3 h into root 3 cos h minus sin h. Okay, how can compute this problem? So 2 times of here. So numerator we can adjust sin a minus b or cos a plus b. Here divide multiplied by 2. So here also 2 dividing. So 2 into 2, 4. 4 times of limit h tends to 0 root 3 by 2. Here I have written cos pi by 6. So sin pi by 6 plus h into cos pi by 6. Cos 30 value root 3 by 2 minus 1 by 2 is sin 30 into cos pi by 6 plus h upon in denominator h place 0, right? Here cos 0 defined, sin 0 is 0 defined. Root 3 h into root 3 cos 0 minus sin 0. So cos 0 value 1, root 3 times of 1 is root 3. So 4 times of here numerator we should use a cos sin a cos b minus cos a sin b. What is the formula? Sin a minus b. Where a is pi by 6 plus h, b is pi by 6. Sin a minus b by root 3 into root 3, how much? 3 h. So 4 by 3 times of, so now we should use here pi by 6 get cancelled. 4 by 3 times of limit h tends to 0 sin h by h. What we get answer? 4 by 3. Thank you for watching. Remaining questions I will explain on coming classes.